Hello, and thank you very much for watching the very first video in my brand new YouTube channel. My initial idea is that I create a series of small videos in which we can together peek under the hood of Apache Kafka and learn more about the way in which they persist our information. Perhaps you all know that our topics are divided into partitions, that each message goes into a partition in a so-called segment file, and there is only one segment file active per partition. The other ones are rotated and archived, and so on and so forth. But besides this very general knowledge, there are a lot of intricacies. For example, what kind of indices are attached to our segment files? Or how does batching affect the size of our segments? Or this is a very tricky question. For how long does Kafka persist our messages? We'll try to shed some light on these issues. If you like what I do, you can support me in the usual way for YouTube. Now we have some work to do. Let's waste no more time and let's start. For the purposes of our demonstration, I have created a local Kafka installation, and I did that by using the binary download, which is available on the site of Apache. This one here. Besides this download, on the same site we can find also a small Apache Kafka quick start guide, which describes how we can unpack the installation and start our own Kafka cluster by issuing just these three commands, this one, and this one. I have copy-pasted these commands in my own shell script, which I'll show you in a moment. No rocket science here. Maybe the only thing that we have to note that if we want to get everything up and running, at the moment we should have at least Java 17 installed. So now let's go into the console and see what we have here. This is the directory where I unpacked the Kafka distribution, and you can see inside, if I list it, the Kafka files and directories. Maybe most interesting is this script here. I can print its contents, and you can see the last three lines are copy-pasted from the quick start guide, and on the first line I remove the directory craft combined logs, which is the directory where by default Kafka persists our data. My expectation is that if I run this script, we'll have a clean Kafka cluster up and running. That's why I named it restart. Maybe I should have thought of a better naming, but that's also fine for the moment. So let's run the script and wait a little bit. Now I believe that we have a cluster which is up and running, and we can go into another console and have a look at the directory craft combined logs. Let's list it. We already have some files here which were just created. The directory cluster metadata is the home of the internal Kafka topic, which is named cluster name metadata. As the name suggests, it contains some information about our cluster. We can see some more internal files here. For example, this meta properties, which contains some information about our cluster. The idea now is that if we create a new topic in Kafka, we will see that its partitions will be stored here. In order to create a new Kafka topic, I will use a small Spring-based Java application, which I'll show you in a moment. Here is our application. I have opened it in IntelliJ. I will not drill too much into its details. If you want and feel like it, you can download it from my GitHub account. I have provided a link down below, but I will give you a short summary about it. It is a web-based application, and it has two endpoints. The first one is create, and as the name suggests, it is able to create a new Kafka topic, and publish is able to publish some messages into this Kafka topic. Of course, initially we have to focus on the create because we still don't have topic with which we can experiment. Let's see how it works. Again, don't pay attention to the details. We will create a Kafka topic with the help of the Kafka admin tool, which is injected for us by the Spring framework. This Kafka admin is able to connect to our cluster because we have provided some configurations here. The most important is, of course, the address of the Bootstrap server, and from the Kafka admin we can create an admin client, and on line 50 we can see how a Kafka topic is created. Our topic is named test-topic, and initially it will have just one partition. The interesting part is this setting, segment bytes. As you maybe know, whenever we publish a message into Kafka, it is stored in something which is called segment, and in each partition there is only one active segment, which is represented, of course, by a segment file. By default, the size of the segment files in Kafka is 1 GB, but this is too much for our experiment. That's why I have overridden this property, and I made it equal to 10 kilobytes. This effectively means that whenever our segment files becomes more than 10 kilobytes, it will be automatically archived and a new segment will be created. Now let's run the app. Actually, it's already running, and we can call now the create endpoint and see what will happen. In order to call endpoints, I will use the built-in REST client of IntelliJ. It is quite easy to work with, and here on line 2 you can see that we send a GET request to our app, which is up and running on port 8080, and we send a request to the create endpoint. Let's run it, and here we can see that it returns status code 200, which means that we already have a new topic created. Let's go back to the console right now, and here we are in the craft combined logs. Let's list the contents of the topic, and here we can see a new directory which is named test-topic-0. Test topic because within this directory we store the data for Kafka topic test topic, and 0 because this is for the first partition. The indices of the partitions are 0 based here. If we had a topic with 2 partitions, the result would be that here we would have 2 directories, test-topic-0 and test-topic-1. Let's go into test-topic-0 and see its contents. And here we can already see some files. These files, the name of the files are numbers. We'll see what they mean in a minute. We have 2 files which are indices, and actually 000000 index and time index. We'll see what is their purpose. And here is the file of our currently active segment. So if we publish a single Kafka message, it will be stored into this file. Maybe you note that the size of the index files is rather big, and we have nothing into our segment file. This may seem a little bit strange, but in fact, if you print the contents of both these files, you'll see that they are empty. These are the so-called sparse files. They are full with 0 bytes, and the operating system is clever enough to optimize their storage. So in fact, they do not occupy any storage on disk, but this is not their actual physical size, this is their logical size. So currently they are more or less empty. Actually, they are absolutely empty. It is time that we publish some messages into our new Kafka topic. We will publish messages by using the publish endpoint, which accepts a parameter which determines how many messages we'll publish. Let's have a look at the endpoint before we call it. Again, there is nothing complicated here. In order to publish something, we use the Kafka template tool, which is set up by the Spring framework for us, and here within a loop we will publish 150 messages because count is 150. So here on line 65, the publication takes place. For key, we take random UUID, and for message, we create our message which contains 64 random alphanumerical characters. So no rocket science in this method, but the idea is that we publish a message with a UUID which is 36 bytes, and the message itself is 64 bytes, so that altogether a single message of ours is 100 bytes. Now let's run the publish endpoint and see what will happen. It ends with status code 200, which means that we already have 150 messages within our topic. Let's go back into the console and list the contents of the only one partition. And now you can see that the things have changed. The new thing is that we have more files here, as you can see, and their names are formed by appending a number at the end. So these are 0 parent and they end in a specific number. This number represents the offset of the first message, which is stored into the segment. So for example, this file, which ends in 00, stores messages which start with offset 0 till offset 57, because the next file starts at 58. So 0 to 57, these are 58 together, and the next segment stores the messages which start with offset 58 up to 115. And currently we also have another segment, which is the active segment. It is still not full. As you can see, the size is 5780 bytes, and it is yet to be rotated. When we publish some more messages, it will be also rotated when it reaches this size. This size because the size is such big because the next message will require a little bit more than 140 bytes, and it would if we publish here one more message, it would exceed the segment bytes configuration which we made. And I remind you that this configuration was 10 kilobytes. Let's try to see what we have into this file. I will print its contents, and you can see that this is a proprietary format. So it's if we try to, it's a no-go to try to reverse engineer it. That's why we need some more sophisticated tool which is able to read the message and print some information about it. The good news is that Kafka comes equipped with lots of tools. They're located in the bin folder. So this is the distribution of Kafka. And if we move to the bin folder, you'll see that there are a lot of tools. But what is common with most of these tools is that they delegate to this Kafka run class shell script. For example, let's see this tool which is able to extract some information about our topics. It delegates to Kafka run class shell. And the Kafka run class shell script starts Java and passes the main class of the tool itself. Usually these are tools which are written in the Scala programming languages and are part of the distribution of Kafka. For example, let's have also a look at the Kafka console producer, which is able to print some messages, to publish some messages in Kafka. And more or less the same thing happens here. We end up with Kafka run class shell, but we provide a different main class. The semi-bad news or the semi-good news is that there are more tools that we can have at our disposal and we can use, but not all of them have their shell wrappers, so we may have to call them manually. For example, one such tool is the dump log segments, which is meant to debug some corrupted segment files, and we'll use it in our case just to print in human readable form the contents of our segment. So I will copy paste it And perhaps just 1 second, I don't need the bin here because I'm already in the bin directory. And let me see what happens. I will print the contents of the first segment, which is already archived. I have to wait a little bit, and now the tool prints a lot of output. I will copy paste it and put it into IntelliJ so that we have a look at it in a more civilized manner. And here is one empty file which I created for the purposes, which is called temp log. And within temp log, I'm pasting the output of the tool. You can see here similar sections. So each of these sections represents a batch of messages, but my batches always contain just a single message. Why is that? This is because I have configured the batch size of my producers to be 1 byte. This means that if my message exceeds 1 byte, which it will always do, then the batch will be terminated and a new batch will be started. So every batch in my current setup has just a single byte. We'll try later on a setup with bigger batch size, so that we can have a look at what will happen to our partitions in this case. So I go here in back before this experiment. Let's have a deeper look at the contents of the batch. We have a base offset, which determines at which offset the batch starts. Last offset, where the batch ends. Here the base and last match, because we have only one message in here. And what else we have here? What else? We have something very interesting. It specifies that the size of the batch is 170 because we have a message which is 100 bytes together with some metadata about the batch and the message itself. So each message in my case will contain 170 bytes because it is published in a separate batch. And here is the message itself. We have some metadata about the message. The key size is 36, as we discussed, because this is UUID. The value is 64 because it contains 64 random alphanumerical characters. So here is the key, and here is also the payload, the message itself. Let's make some calculations now. We go back here, and we can see that our segment is 9,860 bytes. Let's try to calculate how many messages it contains. So we have 9,860 divided by 170 per message, per batch with one message. And not surprisingly, the result is 58. This is the same here. So we have 2 times 58, which makes 116. And the remaining messages are stored into this segment, which is currently active. So we have in total 150 messages. We can subtract 116, and you can see that we have 34 messages left in the active segment. So my expectation is that if we divide the size of the active segment by 34, the result will be 170. Or we can do it this way. You can see that the remaining active segment contains 34 more messages, and that's why its size is that big. Now, a few words about the index and the time index file, which come together with the segment. We can also use the very same tool in order to debug their contents. Currently, as you can see, their size is very small. Initially, they looked like 10 megabytes, but now they are much smaller. And we can print their contents by using the same tool. Let's do that. What we have here? Well, it says that within this segment, which contains 58 messages, the message with offset 25 starts at position at byte 4250, and the message with offset 50 starts at this position. Let's visualize all this so that it becomes more clear. Here is our visualization. Imagine that the green rectangle is our segment file, and down there we have our index, or at least our offset index, offset-based index. And once again, Kafka messages with offset 25 and above start at byte 4250. And Kafka messages with offset 50 start at byte 8500. So my expectation is that if I divide this number to 170, actually the size of one message together with the batch metadata, I will get 25. This means that I have 25 messages before this. So the messages with offset 0 till offset 24. Let's try it. I will calculate 250, 4250 by 170, and as expected, we got 25. If I divide this number, which is twice as big as the previous one, I will get 50, which means that there are 50 messages before that, from 0 to 49. And for example, if we search for Kafka message, or if maybe better said, if Kafka searches for a Kafka message with offset 30, it will start its search at offset 25, and it will read several messages until offset 30 had been reached. It is also worth that we have a look at the time-based index. We can use the very same tool, dump walk segments, to do that. We have to wait a little bit, and we'll see something similar. This time, the contents of the time index shows a timestamp related to an offset. So the timestamp is a Unix timestamp and represents the time in which a given message had been added to the segment file. For example, in this time, the Kafka message with offset 18 was added, and in case that we want to search for this message, we can use the other index, which is actually offset based. So we can easily, if we search by timestamp, we can find the corresponding offset, and based on the other index, we can easily find what we are looking for. How much entries are there in the index and in the time index files is also somehow configurable. We will try to figure out how we can influence the amount of entries. But for the current moment, maybe you have to remember that we have an index and a time index attached to our segments. Actually, this is the reason for which most of the more advanced Kafka tools, for example, this one, which is called Conductor, I'm not affiliated in any way with it, offer searches by, for example, searches by time-based searches. Here you can see within the E01, and they also offer offset-based searches in which we can search by offset in a given partition. Here we can also specify a partition, or we can search within all partitions. But most of the tools that you will use and encounter will offer these time-based and offset-based searches, simply because Kafka maintains these indices which can be used for these two kinds of searches. Before we finalize this episode, I want to make a few more experiments. I will restart now our Kafka cluster. So it's stopped. I will start it again. And we will see what happens if we increase the batch size, what happens with our segments. We are up and running. I want to remind you that when we had a very small batch size, we had 58 messages within one segment. We published 150 messages, and we had 3 segments, 1 active and 2 rotated. Now let's increase the batch size to, for example, 5,000. And we can start our application once again. And what I will do is to create a topic from scratch, because we now have a clean Kafka walk. So let me, example, move, because this directory doesn't exist anymore. So we don't have test topic 0. And now I will create with our REST client, I will create this topic. I'm listing it, and you can see the topic here. And now I will publish 150 messages, and we'll see what happens with the topic. Now, surprise, we have now 2 segments, and one segment accommodates much more Kafka messages because we are using batching. Let's see, in order to see what goes on, we have to use our favorite tool and to see what is the contents of this segment file, of the first archived segment file. We'll start a tool with the first segment. We have to wait a little bit, and I'll copy paste some of the output to our IntelliJ, maybe all of the output. So we can see that this time the batch itself starts from base offset 0 and ends at offset 44. These are all messages, and in this case, one of the batches is not 170 bytes anymore, but it is, let me see where we have it. It has size 4,966, which means that since we have a batch with many messages, the metadata for the batch has much lower overhead compared to what we had previously. So I had lower overhead, and we have more messages within one batch, which results, of course, in smaller files. So we have this batch with 44 and another batch with actually with 45 and another batch with another 45 messages. And after that, the segment had been rotated. So the moral of the story is that the biggest our batches are, the less segments we'll have within the Kafka storage. The last thing that I want to experiment together with you is to change the number of partitions of our new topic. So I will change it to 3, and I have already stopped our Kafka local cluster. So I'll start it once again. And if we go here into the craft combined logs, you'll see that we don't have our test topic. So let's run the server and try to create our topic. I'll run the create endpoint, and then I will publish about 600 messages, perhaps 600 messages. I executed 4 times this endpoint, and these 600 messages will be evenly distributed or almost evenly distributed in our partitions, because we work with random UID, which supposes that we have more or less uniform distribution across the partitions. Let's have a look. Here we have three folders, test topic 0, 1, and 2. And that is because we have three partitions which are zero-based. Their indices are zero-based. And we can have a look, we can pick at the directories of our our partition, and you can see here, for example, we have some log files starting at offset 173, and this means that it has a little bit more than 173 or close to 200, and my expectation is that we'll have similar thing in the other partitions. Yes, more or less so, because here we start at in offset 160, and as you can see, we have some entries within this segment, within this active segment right now. And of course, very similar thing will happen also here. Yes. And that's everything for this episode. That is because it got quite lengthy. In the next episode that I want to record, I will play a little bit with the Kafka settings, and we'll see, hopefully together, how this reflects, how this influences our segments, our indices, and so on. If you liked this video, then please give me a big thumbs up and subscribe down below. Thank you, and I hope to see you soon.